Imagine a vast remote forest. Picture the sun rising on a seemingly ordinary summer morning. Suddenly, a blinding flash illuminates the sky. A colossal explosion rips through the air, flattening trees for hundreds of miles. This is the story of the Tunguska Event, one of the most mysterious and powerful explosions in recorded history. It occurred on June 30th, 1908, near the Tunguska River in Siberia, Russia. The Tunguska Event has fascinated scientists and the public alike for over a century. It left no crater, raising questions about its cause. Numerous theories have emerged, ranging from asteroid impacts to cometary explosions. The remote location and limited technology of the time hampered early investigations. Even today, the Tunguska Event continues to be a source of speculation and debate. The explosion occurred in a sparsely populated area. Eyewitness accounts describe a fiery object streaking across the sky. The blast was estimated to be thousands of times more powerful than the atomic bomb dropped on Hiroshima. The event flattened trees over an area of 800 square miles, and the shockwave was felt around the world. The Tunguska Event remains a significant scientific puzzle. It highlights the potential dangers of near-Earth objects. The event also underscores the importance of continued research and monitoring of our skies. The mystery surrounding the Tunguska Event serves as a reminder of the vastness and power of the universe. The morning of June 30th, 1908, dawned clear and bright over the Tunguska region. Indigenous Evenki people were going about their daily routines. At approximately 7:17 a.m., a blinding light illuminated the sky. A deafening roar followed, shaking the ground and sending shock waves through the air. The explosion knocked people off their feet hundreds of miles away. The first reports of the event reached the outside world through local newspapers. The Tunguska explosion left a scene of widespread devastation. Over 80 million trees were flattened, radiating outwards from the epicenter. The area affected covered an estimated 800 square miles, roughly the size of a major metropolitan area. The force of the blast was so powerful that trees were stripped bare of their branches and bark. The explosion created a searing heat that scorched the ground. Evidence of intense thermal radiation was found in the affected area. The trees closest to the epicenter were completely incinerated, leaving only charred stumps. The heat from the blast also ignited forest fires, further contributing to the destruction. Despite the immense scale of the explosion, there was no impact crater found at the epicenter. This absence of a crater has been one of the most perplexing aspects of the Tunguska Event. It has led scientists to consider various explanations, including airbursts and non-impact events. The Evenki people living in the area were deeply affected by the explosion. They lost their homes, their reindeer herds, and their traditional hunting grounds. The event was also interpreted by some as a spiritual omen, adding to the trauma and disruption caused by the blast. The first scientific expedition to the Tunguska site did not occur until 1921, more than a decade after the event. Led by Leonid Kulik, a Russian mineralogist, the expedition faced numerous challenges. The remote location and harsh Siberian terrain made travel difficult. Kulik and his team relied on horses and reindeer to reach the area. Kulik's initial expedition focused on searching for an impact crater. He expected to find evidence of a meteorite impact, but his search proved fruitless. Despite extensive exploration, no crater was found. This unexpected finding deepened the mystery surrounding the Tunguska Event. Subsequent expeditions led by Kulik and other scientists continued to investigate the site. They collected samples of soil, vegetation, and tree remains. They also interviewed eyewitnesses to gather more information about the event. These expeditions provided valuable data that helped shape the understanding of the Tunguska Event. Despite the efforts of numerous scientific expeditions, the cause of the Tunguska Event remained elusive. The lack of a crater and the unusual pattern of tree damage led to various theories. These theories ranged from asteroid impacts to cometary explosions and even more speculative explanations. Section 5. The asteroid theory. The Tunguska event might have been caused by an asteroid impact. Asteroids are rocky objects that orbit the Sun. A large asteroid impact could cause widespread devastation. The asteroid theory suggests an asteroid entered Earth's atmosphere on June 30th, 1908. The intense heat and pressure caused the asteroid to explode before reaching the ground. This explains the lack of an impact crater at the Tunguska site. While widely accepted, the asteroid theory does not explain all phenomena. Section 6. The comet hypothesis. Another leading theory proposes that the Tunguska event was caused by a cometary explosion. Comets are icy bodies that orbit the Sun. They are composed of ice, dust, and rock. Unlike asteroids, comets are more fragile and can easily break apart when heated. The comet hypothesis suggests that a comet entered the Earth's atmosphere on June 30th, 1908. As the comet approached the Earth, it would have heated up due to solar radiation and atmospheric friction. This heating would have caused the comet to release gases and dust, forming a bright coma and tail. The comet would have continued to heat up as it plunged through the atmosphere. Eventually, the intense heat and pressure would have caused the comet to explode in an airburst. This explosion would have released a tremendous amount of energy similar to the asteroid theory. The comet hypothesis could explain some of the unusual features of the Tunguska event. The presence of bright noctilucent clouds after the event could be attributed to the release of water vapor and dust from the comet. However, the lack of a definitive impact crater remains a challenge for this theory. Section 7. Alternative explanations. In addition to the asteroid and comet theories, several alternative explanations for the Tunguska event have been proposed. These alternative theories range from the plausible to the more speculative. Some scientists have suggested that the event could have been caused by a natural gas explosion. The natural gas explosion theory proposes that a large pocket of methane gas escaped from the Earth's crust. This gas would have risen into the atmosphere and ignited, causing a massive explosion. This theory could potentially explain the lack of an impact crater, but it does not account for the reports of a bright object in the sky. Other more speculative theories have suggested that the Tunguska event was caused by an antimatter explosion, or even a miniature black hole. These theories are not widely accepted by the scientific community due to the lack of supporting evidence. While these alternative explanations are intriguing, they lack the scientific rigor and supporting evidence of the asteroid and comet theories. The asteroid and comet hypotheses remain the most plausible explanations for the Tunguska event based on current scientific understanding. Section 8. Lingering questions and ongoing research. Despite decades of research, the Tunguska event continues to raise lingering questions. The exact nature of the object that exploded over Siberia remains a subject of debate. Scientists continue to analyze data and conduct fieldwork to gain a better understanding of the event. One of the key questions is whether the object was an asteroid or a comet. Researchers are studying the pattern of tree damage, the chemical composition of the soil, and the presence of microparticles to determine the object's origin. New technologies and analytical techniques are being employed to unravel the mystery. Another area of ongoing research is the potential for future Tunguska-like events. Scientists are actively monitoring near-Earth objects to assess the risk of future impacts. Early detection and mitigation strategies are being developed to protect our planet from potentially hazardous asteroids and comets. The Tunguska event serves as a reminder of the dynamic nature of our solar system. It highlights the importance of continued research and monitoring of near-Earth objects to protect our planet from future impacts. The ongoing research will hopefully provide more definitive answers to the lingering questions surrounding the Tunguska event. Section 9. Tunguska in popular culture. The Tunguska event has captured the imagination of the public and has become a popular subject in books, films, and video games. It has also been featured in documentaries and educational programs, often portrayed in science fiction as a result of alien encounters or advanced technologies. Featured in disaster films, showing potential consequences in populated areas. The event serves as a reminder of nature's power and the importance of scientific inquiry. Section 10. Lessons learned and future preparedness. The Tunguska Event provides valuable lessons about the potential hazards posed by near-Earth objects. It highlights the importance of early detection and mitigation strategies to protect our planet from future impacts. The event also underscores the need for international collaboration in planetary defense efforts. The Tunguska Event demonstrated the destructive power of even relatively small objects entering the Earth's atmosphere. The explosion over Siberia was estimated to be thousands of times more powerful than the atomic bomb dropped on Hiroshima. A similar event occurring over a major city could have catastrophic consequences. Scientists are actively working to develop early detection systems to identify potentially hazardous asteroids and comets. These systems use telescopes and radar to track near-Earth objects and assess their risk of impacting our planet. Early detection is crucial for implementing mitigation strategies. Mitigation strategies include deflecting or disrupting the trajectory of a potentially hazardous object. These strategies involve using spacecraft to nudge the object off course or using nuclear devices to break it apart. International cooperation is essential for developing and implementing these strategies effectively. Section 11. The Enduring Enigma. The Tunguska Event remains one of the most intriguing mysteries of the 20th century. The lack of a definitive impact crater and the unusual pattern of tree damage continue to puzzle scientists. It has led to advancements in our understanding of asteroids, comets, and the potential hazards they pose to our planet. The Tunguska Event continues to inspire awe and wonder about the universe.